All right, if you're looking to find all the measures of this particular type of triangle, if you were to sketch in what you have, okay, just label your pieces 5, 12, and 13. Okay, and then you just assign one of the angles. So I'm going to call this angle A, B, and C right here. So the one that we know for sure, C, is 90 degrees, right? Okay, how can we find angle B? With respect to B, we know all three sides, so you can pick any trig ratio you want. Let's say we pick the adjacent side, 12, and the hypotenuse, 13. Which trig ratio relates adjacent and hypotenuse? Cosine, right? So we can set up our ratio. The cosine of B is equal to the adjacent, 12, over the hypotenuse, 13. If you set up that ratio, you can then find angle B by calculating the inverse cosine of whatever that ratio was. And when you do that on your calculator, the inverse cosine of 12 over 13, and hit enter, you get your angle to be 22.6 degrees. So this angle is 22.6 degrees. Okay, so that means finding A is possible a couple different ways, right? So what's the simplest way to find A? What do you know about A and B? They have to add up to 90 degrees. So easiest thing to do, if we just took 90 and we subtracted the measure of angle B, that's going to give us A, which is 67.4. Okay, but we can also confirm this using any trig ratio. So what if we use the ratio A and we took the side opposite it, 12, and the side adjacent to it, 5? Which trig ratio relates opposite and adjacent? TOA, tangent. So I know that the tangent of A is equal to opposite 12 over adjacent 5. Therefore, A itself is going to be calculated as the inverse tangent of that ratio. And so if I do the calculations, green diamond T to access tangent, 12 divided by 5, and I hit enter, I get my answer to be 67.4. It confirms exactly the measure I was expecting to see.